Started. Good morning. Alright, so today we are learning fraction operation. So a few things we're gonna review first. We're gonna review the order of operations, what's known as bad math. We are also gonna learn the concept of terms, rearranging terms, combining and split numbers before we get into the lesson itself, okay? So you may not be familiar with this topic, or maybe you learn it differently. It's always good to see things from another perspective to learn how a teacher would tell you. Okay, so first of all, terms. Okay, it's important for everyone to tune in. James, tune in. Okay, terms. Okay, I'm gonna write down a statement. You let me know how many terms I have, okay? I'm not asking you to solve this. Do you know how many terms I have here? Terms. Raise your hand if you think I just have one term. 2 terms? 3 terms? 3? Raise your hand if you think you have 3 terms. Anyone agree with Kevin and James? 4 terms? 4? 5? 6? No idea? All right. So if you want to know how many terms you have, you're going to take a look at how many plus and minus signs you have. All right. The reason why is, you see, if you have multiplication and division, ultimately they will be one number, all right? And then you worry about the additions and subtractions. So you have one term over here, another term over here, another term over here. It's important to identify the terms because this is why. Because once you identify the terms, you can start to rearranging things. Rearrange terms. Say, for instance, if you have -2 plus 3 minus 7 plus 6, right? In this case, can you tell me how many terms I have? How many terms do I have? 1 term? 2 term? 3 terms? 4 terms? 4, thank you. So again, identify the plus and minus 1, 2, 3, 4 terms, right? Once you identify them, we can rearrange this. When you move things around, be sure that you stick the sign to the number, okay? See, that it's a -2, that's a +3, that's a -7, that's a +6. You can rearrange this in a way so that the positives are together and negatives are together. I'm gonna put these positive numbers together, and I'm gonna put negatives together. Okay, so in this case, you can add how many positive numbers you have, what are the positive number sum, what are the negative number sum. In this case, the positive add to 9, the negative add to 9 as well, and the answer is 0. Okay, so it's important that you recognize that you can actually rearrange in your terms. Over here, I can rearrange my terms. I can move this 3 units, so I have to recognize that I have 3 units, 3 different terms. I can rearrange in them without changing, what the outcome would be. Okay, it's important that you know how to do that. Thirdly, combine and split numbers. Okay, what I'm showing you is our concept, and it will come handy once you want to solve some questions. Say -99 plus 6 minus 3, okay? Usually, your elementary school teacher would say, Let's do things in order from left to right. You take 99 plus 6, and then find the result, then you minus 3. That's how you were taught, right? But once you know how to rearrange in terms, you can make things easier. I have 3 terms, yes? And I can rearrange in them. I can put all the positives together, and then the negatives together. All good? And then I can realize that, hey, I'm gonna find out what are the sum of the negatives. What's the sum of the negative? Negative 102, positive 6, and then you find out the answer, right? When you are subtracting smaller number to larger number, you can just take the larger number and minus the smaller number. You know the outcome is gonna be negative, right? And then in this case, you take 10 from here, minus 6, you got 4 left, you got 6 in ones, and then you have 9 over here. Okay, so negative 96 would be your answer in this case. So far, so good? So what I'm trying to say here, yes, you can do this. You have your ways. You can go from left to right, but sometimes when you are rearranging things, it could be easier. Oh, talking about splitting, I did not really show you splitting. So I'm gonna take this line over here, 6 minus 102, okay? Say I continue from here. Of course, I could go and take 102 minus 6 and then put a negative number there. But what I could also do is I'm gonna rewrite this negative 102 as 6 minus 100 minus 2. Can I do that? Yes? Okay. Why do I want to do this? Because in doing so, I can do this part in my head, can I? Yes? So this part in my head would be what? 94, negative 94 minus 2, negative 96. In that case, I don't need one of that. Okay? When you learn to split numbers into easier number to work with, you can just solve it in your head. Okay, it's important to have those concepts. And now, I'm going to go into what we're learning today. Oh, we didn't copy that down. There we go. Okay, thank you for stopping me. Sometimes I tend to speak and write things a little bit faster. All good? All good. All right, moving forward. You may know this acronym of, let me see, BEDMAS. Okay, we're going to review this a little bit. You're actually going to write this as BE-DM-AS. The reason why is we're going to do the bracket first and then do the exponent, and then division and multiplication. You can decide which order you want to do. Okay, you can do all the divisions first and then all the multiplication, or you can do one at a time. Doesn't matter. Okay, and then you do your additions and subtractions. Doesn't matter the order. Why do I say it doesn't matter the order? Let me show you. Okay, I'm gonna leave the exponent and bracket out first. I'm just gonna focus on this part. Okay, say if I have negative 3 divided by 9 plus 5 here. How many terms do we have here? We have 2 terms. 1 term, 2 terms. All right, so we got to simplify each term. First term, I have negative 3 divided by 9. This would be equivalent of negative 3 over 1 times by the reciprocal 1 over 9 plus 5, and this will give me negative 3 over 9. Oh, before I do that, notice I can simplify this. So 3 divided by 3 give me 1. I'm gonna put the negative next to it just so that I don't omit it. 9 divided by 3 give me 3. So this should be negative 1 over 3 plus 5. Alright, now we're running into negative number. I can't put this 5 and negative 1 over 3, so I'm gonna say, I'm gonna take one of these ones and minus that. Actually, let me write that out. I'm gonna say 5 minus 1 over 3. Okay, since I'm rearranging them, that negative 1 over 3 becomes minus 1 over 3 plus 5 in the front. And I will have 4 and what? 2/3. That's my final answer. Okay. And that is that. Okay. Next example, I have 1/3 times by bracket 9 minus 2 minus 5 over 6. How many terms do I have? One term? 2 terms? Who says 2 terms? Thank you, Sandy. Yes, we have 2 terms. Whenever you have a bracket, you have to see this as 1 unit. Okay? So that is 1 term. That's another term. You can rearrange in them if you wanted to. If I want to write negative 5 over 6 plus that unit, which is also fine. Okay, but in this case, I'm gonna leave it as it is. If I have bracket, I need to simplify that first. Again, I'm trying to simplify each term. In the first term, this bracket is 7, and I'm gonna write it as 7 over 1 because I'm multiplying what? Fractions. Okay, I'm gonna make everything fraction, and minus 5 over 6. So again, this term could be further simplified. Top times top, bottom times bottom, 7 over 3 minus 5 over 6. It's very important to recognize that I have operation between 2 terms. I'm not multiplying, I'm not dividing, so don't times the top number or anything. When you have fraction in separate terms, you gotta have same denominator before you subtract them. Okay, if the denominator are not the same, you can't subtract them. So I need to change this fraction so that its denominator says 6. I'm gonna do that on the side for you. 7 over 3. I need this to turn to denominator 6. Okay, so from here to here, I have to times this by a fraction that is 2 over 2. Okay, so when I do this, I will have bottom turn to 6, top turn to 14. Why is it 2 over 2? Well, because I see that if I take 2 times 3, I get 6. And 2 over 2 is just 1, right? If I take anything times by 1, I'm not changing the number itself, okay? I'm getting an equivalent fraction. From this fraction to that fraction, those are equivalent. Therefore, I get to rewrite this as 14 over 6 minus 5 over 6. If this is if the denominators are the same, I could combine them. Okay, this is how you do it. Just write a bigger fraction, then 14 minus 5, and here you have 14 minus 5 give you what? 9, thank you, over 6. 9 over 6, you may tend to turn that into a mixed number already, but notice that I have common factors. That is 3, right? 3 goes into 9 3 times, goes into 6 twice. This is actually 3 over 2 as a mixed number, 1.5. Again, how do you figure that out? 3 divided by 2 going into 1s, and I stop there. 1 and 1/2. Okay. One more of this simple questions, and then I would like to show you another question from your book. It says 2.5 divided by 2.5 divided by 1 3/4. Sorry about this. 1 3/4 plus 1 1/4. Okay. So how many terms do we have here? Altogether, we just have one term because that's a bracket. You can say you have two terms in the bracket, but you got to simplify what is in the bracket. So first of all, take a look at what is in the bracket. 1 3/4 is equivalent to 1 plus 3/4 plus 1 plus 1/4. So altogether I have 1, 2, and these fractions add up to 1 as well. So I have 3 over here. 2.5 divided by 3. Alright, so divide by 3, it's equivalent as times 1/3. 2.5, I'm gonna change this to improper fraction because I'm doing a multiplication. This would be, that 2 would be 4 over 2, 4 parts in 2, and altogether I have 5 parts. There's nothing to simplify here, so I'm just gonna multiply the top, give me 5, multiply the bottom, give me 6. And that is proper. All done. That's the answer to this. Maybe a word question, maybe a couple word questions. I'll give you more time to work on your homework. Okay, a question printed over here. Alright, it says Ron earns $15 per hour as a security guard. For-time work above 35 in a week, he earns time and a third. How much does Ron earn for a 41-hour week? Okay, so you have to draw a little bit. You can say this is the hour work. Okay, and you can call this rate. For 0 hour all the way to 35 hours, the rate is $15 per hour. Okay, so for each hour you earn 15, 15, 15, 15, 15, 15, so on and so forth. This is not to scale, this is just to help you understand the question. Over 35 hours though, for each hour and above, you're gonna earn how much? What does it say? Times and a third. So it's gonna say 1 and a third. You're gonna earn extra third, correct? Of what? Of 15. That's the rate. Okay, you're gonna earn the extra third of that $15 as bonus. Now, how much does Ron earn for 41 hours? So he worked 41 hours. Okay, how do we figure out his salary? Suggestion? James, have you been following? How do you find out his salary if he worked 41 hours? So up to 35 hours, he earns $15 per hour. Beyond 35, he earns 15 times a third. How do we lay this out as formula? Okay. Can we figure out the earning in that part first? Yes. And then we can add on to earning in that part. Okay, in the first chunk, we know he worked 35 hours. Well, he learned 40. He actually worked for 41 hours, but in the first 35 hours, the rate is the same. That it's $15 per hour. Okay, so over here, every hour, it's 15 times 1 1/3. This is per hour. How many hours did he work? So from 35 to 41, right? Would be 41 minus 35. That would be how many that would be how many hours he worked, and times the rate. It's getting a little bit complex, yes? Yes? Okay. And this in the middle is plus. When we have the formula, okay, how many terms do I have? Terms? One term? Anyone for one term? Anyone for two terms? Two terms? Two terms it is, okay? Because that's multiplication, that's addition right here, and therefore that whole thing is the term, okay? Means that we have two chunks. One chunk for first for one part of the salary, another chunk for the other part of the salary. Then you can figure this out independently. So we can talk unit later on, but this unit, this altogether is gonna be dollars when you figure this out. So 35 times 15. I'm gonna do this on the side. Oh, right here. 35 times 15. Again, if you're a little bit rusted on how to multiply two digits, tune in, okay? So I'm gonna write this as two different set of numbers. 5 times 5, 25. 5 times 3, 15. And then for the result of ones, I'm gonna put it right underneath here. It's gonna be 35, okay? And then I add things down. 5, that would be 12, and that would be 5. 525 is his earnings for 35 hours, okay? If he doesn't know how to do math, he will always work 35 hours. You know why? Because he doesn't know how much he earned beyond that. All right, so in order to figure out how much he earns on the hours beyond 35, let's figure out how many hours first. So this part represents how many hours. 41 minus 35 would be what? 6? Is it 6? From 35 to 40, it's 5. Do that in your head. And then from 40 to 41 is extra 1. So it's 5 and 1, right? And then 35 times a third. How do you do 35 times a third? Sorry, 1 and a third. Sorry, 15. Sorry, 15 times by, I'm going to change this to improper. I'm going to change this to fraction. I can multiply this out. Okay? Now, notice that I can simplify this. Divide top and bottom by 3. So 3 goes into 3 once, goes into 15 5 times. Bottom would be 1, top would be 20. Yes? I have 20 over 1, therefore 20. So I have 6 times 20 here for the second part, and first part, just write it down again. 5 to 5. And I have 5 to 5 plus 6 times 20, 120. And if you can't do this in your head, just do some extra work, it's fine. 5 to 5, 1 to 0, add it down. 5, 4, 6, 645. That's not your answer yet. Let's go back to the question. The question is asking for how much does Ron earns in a week. So that's the dollar amount. You can answer Ron earns $645 for 41 hours worked. Box your answer, then that's your answer. Okay? You can make this shorter, such as you just put R instead of Ron, or somehow make the sentence shorter, it's fine. But you need to formulate it into a sentence rather than simply say, hey, 645. 645 what? Cents? Minutes? It doesn't answer the question. Okay? One more word problem before I let you go. Okay, so this is in the camera. All right, example number 2, this guy, okay? Beth earns $25 an hour as a machine operator in a sawmill. Full-time work, oh, this is exactly the same, isn't it? I'm gonna skip this one, okay? It's gonna be the same as the one before. There are a few things that I'd like to let you know. Okay, I'm gonna stop the recording. Yes, and I'll put this up. Okay, so we're gonna review these three concepts quickly. Won't take long. First of all, convert between fraction and percent. How do you do that? If you have a fraction, let's start with a proper one. Say 3/5. Okay. How do we turn this into a percent? There are a couple of ways. There are many ways. First, you can see that this is 3 divided by 5. Therefore, you go 3 divided by 5. Doesn't go into any time. Therefore, you got to go to the decimal 6 times. So this is equivalent of 0.6. It's equals to, what is percent? Percent is what? Divide by 100. 0.6. I can't simply put that divide by 100 next to it. It's not fair. Okay, I can't just change the number. In order to put this percent sign next to it, I have to times by 100. So times by 100 divided by 100. This would be equivalent of writing 0.6 times by 100 over 100. I'm not changing anything, right? By keeping divide by 100 as a percentage sign, this would be 60%. Okay. Now, if you're doing the reverse, if you start with 60%, and Mr. Chen wants you to convert this to fraction, you just have to realize you can rewrite this as 60 divided by 100, or 60 divided by 100 as a fraction, and you can simplify this as what? Divide by 2, 3 times 5 times 3/5, and you have fraction. Okay, so that's a quick review of how to convert between fraction and percent. Again, if you learned this already in the first go, then you just have to maybe review it a little bit. Perfect square. What are perfect squares? Perfect squares are, you can, as a picture, it's the same length but all 4 sides, and these are right angles. If this area is 25, by definition, the side length is going to be square root 25, and we see this number as 5. Yes, 5 times 5, so I can say, oh, 5 times 5 is 25. Square root 25 times square root 25 is also 25. Okay, 5 is square root 25. They are equivalent. That's our perfect square. So in this case, I can say, hey, if the area is, I don't know, 36, is this a perfect square? Yes, this will be a square with side length of 6, so that this area will be 36. If I say this area is 37, is this a perfect square? No. Well, you would still have side length at 6 point something, but this number needs to be an integer for it to be a perfect square. Okay? All good? Next, estimate square root. If I say I have a square with the area of 37, you're going to draw this out as 37. Each side is square root 37. Well, I may ask you, well, what is square root of 37 then? What is it? Okay, you're going to tell me, well, it's going to be less than 6, because from here you can see that 6 is equivalent to square root 36. 7 is equivalent to square root 49. Okay, so it's going to be somewhere in between. 37 is closer to 36. It's going to be close to 6, maybe 6.1. Okay, what I did not tell you last time, so this would be new. Can everyone make sure you take note? on this part. Okay, so from 6 to 7, I'm gonna divide this into chunks. Are you listening? I did not tell you this when we first learned this. Okay, so to estimate better. Okay, I'm gonna label this as, so you count with me, okay? Ready? From 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, and 49. All right, so let's count how many chunks we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 chunks. Okay, I'm gonna write a fraction here as representing 6 and something over 13. Okay, 13 steps, all right? 13 steps, 37 falls into here, square root 37. So 1 step out of 13 steps, okay? So I could estimate square root 37, it's gonna be approximately equals to 6 and 1/13. Okay, 13 being how many steps, and 1 being how many steps. So if okay, so in this case, this would be 6 point something. If I want to figure out the decimal, 1 divided by 13, that doesn't go. I gotta keep going. 100. Okay, so 13 going to 100 how many times? Want to take a guess? Want to say, I don't know, 9 times? No, maybe 7 times. Let's try 7. 91, good enough? Yeah. So times 7, 91, and I will have what? 9 left, right? So, and then there's more numbers here, and this is gonna be 6. $78, something like this, right? So this would be 6.076 and more, okay? So I can say square root 37 is going to be equivalent or approximately equals to 6.076. All good? Okay, so if I'm asking you and you are not really sure either this is going to be 6.1 or 6.2, count how many steps and write this as a fraction. Again, if I'm asking you, hey, how about square root 41? 41, okay? In that case, you just have to find where 41 is. 37, 38, 39, 40, 41. That guy is going to be 41, okay? So 41 is going to be approximately equal to 6 and how many steps in 13 steps? 1, 2, 3, 4, 5. All right? Then you can say this is 6 point something, and then you figure it out from here. Okay? Sorry, that'd be 13. All right? So I'll leave it there. All right? So again, this is a way that you can estimate better. You can find out more accurately what this square root is going to be. Okay? And that is everything in the review for DejaVu part.